So at what angle should a ray of light be incident on the face of a prism of refracting angle 60 degrees? So this refracting angle of the prism, they are the same thing. Still refers to that peculiar angle of the prism. We are told that the prism has a refracting angle of 60, so that it just suffers total internal reflection at the other face. The refractive index of the material of the prism is √2. So let's quickly sketch a right-angled, a triangular prism. So if we have this as a triangular prism, this refraction angle A is what is given as 60. We are told light incident here. Once the light at the other face is not perpendicular to the face, it will certainly deviate. So it will deviate at the first refracting surface. But we are told that at the other surface, the light incident in such a way that total internal reflection occurs there. So what is this least angle of incidence where total internal reflection would occur? So N2 and the reflected ray must be on the boundary for total internal for the critical angle. Don't forget that the requirement for total internal reflection to occur is that the angle of incidence in the more dense medium must be greater than the critical angle. So whenever we determine the critical angle, then we know total internal reflection can occur. Okay, because we know that for total internal reflection, yes, the angle of incidence in the more dense medium must be greater than the critical angle. But the critical angle is the requirement. So this is R1, this is R2. When we extend the first normal, yes, we have this. So for us to get an emergent ray of 90, it means that R2 must be equal to the critical angle of the material for us to have total internal reflection occurring. Therefore, we know R2 is equal to the critical angle. If R2 is equal to the critical angle, then we know the angle of the prism or refraction angle is equal to R1 plus R2. And so we can say that this will still be equal to R1 plus the critical angle. Okay, knowing A, angle of the prism, we need to determine the critical angle in order to find R1. So critical angle sine C is equal to 1 over the Absolute refractive index of it. Knowing it. Please, if you haven't muted, do that. I'm getting a feedback. Biny. Okay. I've managed to bind Biny. So, what is the refractive index of the glass? Yes, class, what is the refractive index of the glass as given in the question?
Root 2.
So this is root of 2. Therefore, E is equal to the sine inverse of 1 over root 2. And this is 45 degrees. So we found the critical angle. And it means that for total internal reflection to occur, R2 must be greater than 45. So this would also help us get the least angle of incidence at the other phase where total internal reflection will occur here. Okay, so if C is this, then it means R2 is equal to 45 degrees. Therefore, R1 is equal to A minus C. A is 60 minus 45. So the first angle of refraction at the first phase is 15. Okay, we can therefore find the angle of incidence by using Snell's law. Snell's law, that absolute refractive index is equal to the sine of the angle of incidence to the sine of the angle of refraction R1. And this will be equal to, refractive index is root 2. So root of 2 is equal to sine of I over sine of 15 degrees. Therefore, sine I is root 2 times sine of 15. Please help me get this product. Root of 2 times sine of 15. Root of 2 times sine of 15.
0.3660.
0.3660.
Okay. 660. Therefore,
Yes, sir.
I is a sine inverse or arc sine of that. And that is equal to, is it 21? Approximately 21.
Yes.
Okay. So that's the angle of incidence. The least angle of incidence which will cause total internal reflection to occur. Please, any question before we move on to question 2? Is there any question? Please, how many of you tried Anita?
Yes, sir. Please have a question.
Okay.
So from this question, are you saying that total internal reflection can occur when the angle incident than the critical angle for total internal reflection to occur.
Exactly. So what by this value, what we are saying is that when I is equal to 21, we'll have the emergent ray lying on the boundary at the other refracting plane. So if this A, B, C, what we are saying is that at this angle of incidence, the emergent ray will lie along AB. Anita, are you okay? Anita, are you okay?
Could you go over again?
So any
No.
at I is equal to 21 degree, the refracted ray, the emergent ray will be on the boundary. For total internal reflection, don't forget R2 must be greater than the critical angle, which we've just seen to be 45. It means that I must also be a bit greater for total internal reflection to occur. But to get the requirement for total internal reflection, you must get the minimum angle of incidence, which is this 21. Anything greater than 21, total internal reflection would occur within the prism. Are you okay?
Yes, please.
But we always state the minimum because we are saying anything greater than 21. You cannot, we have list of countless number of angles greater than 21. So which one would you precisely write? So there is a need for us to write that least angle of incidence, which will start the critical angle. That is why our answer is 21. But in actual fact, for total internal reflection to occur, the angle must be greater than 21. So knowing this, then you can be able to, determine how TIR will occur in the prism. Have I answered your question?
Yes, please.
Okay. Have we exhausted the questions? Let me see by hand those of you who got this correct. If you got it right, let me see you. Okay. This particular question. Okay. All right.
Sir, I got
Hello.
21.5.
You see, you got 21.5 because, let me see, the refractive index is √2. Good. Maybe you changed this into decimal, 1/√2 to decimal. And because you cannot write everything, what 1/√2, okay, would give you 0.7007. But because you cannot copy everything, you round it up to a certain number of decimal places. That is why you had point something in addition to it. Are you okay? So you are not wrong. You are not wrong. Yasmin, is your hand up?
Yeah.
Hello, is your hand up?
Yes, the first was for those who got a question wrong.
Okay, all right, then you can put your hand down. Let's look at the question 2. A ray of light passing through a prism having refractive index of √2 suffers minimum deviation. This part is very, very important. We are told it suffers minimum deviation. It is found that the angle of incidence is double the angle of refraction within the prism. So it is found that I is equal to 2 times the angle of refraction. What is the angle of the prism? What is the angle of the prism? Refractive index is equal to root of 2. We are told its surface minimum deviation. Its surface minimum deviation. Please, this statement is very, very important because you see, refractive index of glass prism can be sine I over sine R, which is also equal to sine of the minimum deviation plus the angle of the prism over 2 over sine of A over 2. We use this equation at the minimum deviation, meaning that at the minimum deviation, Gideon.
So the formula is in the numerator there's no plus. It's only minimum deviation over 2.
So there is plus A plus the minimum deviation over 2. Let me explain to you why this is it. You see, total deviation is equal to I plus E minus A. Class, are you with me? And at the minimum deviation, we said angle of incidence is equal to the angle of emergence, meaning at the minimum deviation, we don't have separate angle of incidence and separate angle of emergence. They are all the same. So if at the minimum deviation, we can have dm, which is the same as sigma m, is equal to 2i minus a. So Gideon, if I'm to make I the subject, clearly a must go to the other side of the equation. And I'll have 2i is equal to a plus, oh, please mute yourself, Maurice. A plus this. I therefore is equal to, when I divide through by 2. So, what, Gideon, are you okay? Gideon,
Yes, sir,
are you okay?
thank you.
All right.
Yes, sir.
Okay. So, please, when you are solving these questions, you must read the question to understand if it is a condition of minimum deviation or not. Okay, this would determine the kind of formula to use in solving the problem. So because it is at minimum deviation, and I'm told that sine I is 2 times the angle of refraction, it means this I here must be equal to 2r. I is twice this, divided by sine r. Okay, don't forget, at the minimum deviation, A is equal to 2r. And so r would also be equal to A over 2. We can also look at it from that side. Are you okay? We can also look at it from that side as well. And so if this is the case, then we can determine the refractive index. The refractive index is given. Therefore, let's simplify the numerator. If you simplify sine 2r, this will give us 2 times sine of r times the cosine of r, all divided by sine r. We have gone through this before. If you have sine A plus B, expansion of sine A plus B is equal to sine of A times the cosine of B plus cosine of A times the sine of B. And this is when you have compound angles A and B. Over here, sine 2R is the same as sine of R plus another R. Okay, so if we use this rule to expand it, we'll have sine of R times the cosine of R plus cosine of R times the sine of R. And multiplication is commutative. So sine R cos R is the same as cos R. So this is the same as 2 times sine R times the cosine of R. And this is the expansion of sine 2R. Please, are we okay? Class, are we okay?
Yes.
Please, why isn't it 2 cos R?
Why isn't it?
2 cos R.
No, you see, over here, cos R times sine R is the same as sine R times cos R, because multiplication is commutative. That is how come we are getting twice of sine R cos R. Please, are you okay?
Yes, sir.
Okay, so that is how come the numerator sine 2R is expressed as 2 sine R cos R, because of the expansion. If this is the case, then sine R can cancel sine R. I think this is where you are actually coming from, so that the refractive index is equal to 2 cos R. Having given the refractive index to be root of 2, you can divide through by 2 to find cos R. So when I divide through by 2, I have cos R being equal to root of 2 over 2. So that the angle of refraction R is equal to the cos inverse of root of 2 over 2. And the cos inverse of root 2 on 2 is equal to 45. Okay. What does the question demands from us? The question says that what is the angle of the prism at when the rays surface minimum deviation? And we know that at minimum deviation, A is equal to 2 times R. So if R is 45, then the angle of the prism will be 2 times 45, which is 90 degrees. That is a solution. Please, are we fine? Class, are we okay?
Yes, sir.
Yes, sir.
Hello?
Sir, I don't still understand how you got the cosine.
Oh,
The
you see how I'm listening. How we got what? Oh,
He
whoever
said
asked
the
the question,
cosine. He said he doesn't understand how he got a cosine.
just the cos r is equal to root of 2. Is it this part?
He
Is
said
it
the
this part?
cosine. I think so.
Okay. Whoever asked the question must respond. So we
Sir,
came to
it's just I was asking how you got the two sign R and a call R over. So like, can you go back to the previous slide so I can?
yes. Is it how we got this part? Is it this part?
Yes, sir.
So the question says that at the minimum deviation, the angle of incidence is equal to 2 times the angle of refraction. Okay. And so the refractive index, which is sine of I over sine of R. Under this condition, I is equal to 2R. So substitute 2R for I. So we have the refractive index giving us sine 2R over sine R. Please do not make the mistake to perceive this as sine R 2 over sine R so that you cancel out to have 2. That is wrong. What we have at the numerator is a double angle. Okay, so you must use this identity to expand it. And the identity we are using is when you have two different angles, sine A plus B, the expansion of this is sine of A times the cosine of B plus cosine of A times the sine of B. This is the identity, okay, to be used in expanding this. What we have is a double angle. Sine 2R is the same as sine of R plus another R, true or false. Is that correct?
Yes,
Yes,
please.
sir.
So use this, use the expansion of compound angle, this rule or formula to expand sine R plus R. Okay, so sine 2R would therefore be equal to sine of, is the same angle, only that is double, sine of R times the cosine of R plus cosine of R times the sine of the same R. But multiplication is commutative, meaning that A times B is the same as B times A. So this part will be the same as sine R times cos R. It doesn't matter which one comes first. So it means that sine 2R would give us 2 times sine R times cos R. This is equal to the expansion of sine 2R. Come and substitute it here. And you have 2 sine R times cos R divided by sine R again. And since 2 multiplies sine R and also multiplies cos R, you can now cancel sine R out to be left with 2 times cos of R. So please, if you asked, this is the whole information. Then, meaning that the refractive index N is equal to, we have simplified the numerator to be 2 cos R over, 2 cos R. Substitute the value given as the refractive index, that's √2, and look for R. So eliminate 2. When you divide 2 by 2, you have this, okay? R therefore is equal to 45 degrees. And since at the minimum deviation, A is equal to 2R, once you have R, you can find the refraction angle of the prism, which is 2 times 45. Please, are we okay?
Yes, sir.
All right. So that's the solution to I'll give you another similar but tricky one today as well. Gideon. Gideon. Okay, class, take this question.
So please, you said as you remind you that how to pick a scale for the graph.
I'll go through it. The angle of minimum deviation, please, it's a question. The angle of minimum deviation for a glass prism with refractive index equal to √3, the angle of minimum deviation for a glass prism with refractive index equal to √3 equals the refraction angle of the prism equals the refraction angle of the prism. Full stop. Let me go over. The angle of minimum deviation for a glass prism with refractive index equal to √3 equals the refraction angle of the prism.
Sir, please can you repeat that sentence?
The angle of minimum deviation for a glass prism with refractive index equal to √3 equals to the refraction angle of the prism. Equals to the refraction angle of the prism. What is the angle of the prism? Saki.
Sir, this I can't get it clear. Can you sir, please, can you say that again?
Let me write. So the angle of minimum deviation for a glass prism with refractive index equal to √3 equals the refraction angle. The refraction angle of the prism. What is the angle of the prism? What is the angle of the prism. Start work. 7 minutes will do. So I'm giving you 7 minutes to try your hands on the question. Some of you are actually complaining of network problem.
Me too. My network is not even strong.
Yeah, I think today's network is some way. Okay, so if you go
It's
off,
also raining
please.
at my end.
Yes, it's cloudy here as well. And whenever it rains, then wahala. So you keep on retrying, it will be fine. Okay. Moreover, I'm also recording. You have 4 minutes. Yes, who has managed to finish? Has somebody finished? Okay, because we have some other things to do, let me go through it with you. Okay, so let's solve it together. Okay, now before we solve this question, let me give you a second approach to this one. Some of you also use a different approach, and in fact, it's just nice that we look at theirs as well. We were told that I is equal to 2 times the angle of refraction. Please, are you there?
Yes, sir.
If we use the refractive index at the minimum deviation, we have this. D minimum plus A over 2, all divided by sine of A over 2. At the minimum deviation, we have 2I minus A. That's how come we make I the subject to have what is in a bracket. So if I is equal to 2 times R, okay, and at the minimum deviation, we know that A is equal to 2R. A is equal to 2R. Then it means that this information they gave us, that I at the minimum deviation, A is equal to 2R, I is equal to A. Please, do you agree? Do you agree here? Do you agree with me? If at the minimum deviation, we are told that I is equal to 2 times R, and we know from the theory that at that same point, A is equal to 2R, then we can say that at the minimum deviation, the angle of incidence is equal to the refraction angle of the prism using this and this. Class, are you okay? Hello, are we okay?
Yes, sir.
The rest of you are quiet. What's the problem? So if I is this and A is equal to 2R, then I is equal to this. So when we substitute A for I, we have the minimum deviation being equal to 2A minus A, because I is equal to A here. Okay, so we have dm equal to A.
Yeah.
Hello. dm equal to, hello. Can you hear me?
Yes, sir.
Yes,
Can you?
please.
Okay.
Yes, sir.
So if the minimum deviation is equal to A, and we have the refractive index being equal to sine of, substitute whatever we have for dm. dm is A. So A plus A divided by 2 is A. All divided by sine of A over 2. Okay. Now, Saki.
Sir, please,
Hello,
I've
Saki.
gotten my answer.
All right, we'll look at it. Half plus half is equal to A. So I can write the numerator as sine of half A plus another half A. Please mute yourself if you haven't done so. Morris, mute yourself. When we expand the numerator using,
I'm coming.
when we expand the numerator using the identity I gave you, we'll have 2 times sine half A, or A over 2, times cos A over 2, all divided by sine of A over 2, so that this sine will cancel this. Sine A over 2 will cancel sine over A over 2. And our final results will be 2 cos A over 2. Knowing the refractive index to be root of 2, when we divide 2 by 2, we will have cos of A over 2. Okay. If we take the cos inverse of this, it will give us this angle, which is A over 2. So cos inverse of root 2 on 2 would give us 45.
Sir, it's
Hello?
root 3. Sir, please, it's root 3.
No, look at it from here. This is what I'm saying. No, I don't mean this question. I'm giving you alternative answer solution to the first one we solved. Okay, we haven't
Okay, sir.
yet come to this one. So
Okay, sir.
A therefore is equal to 90. You see, in the first approach, what the method we use gave us R. Then because A is 2R, okay, we multiply by 2 by whatever we had for R, 45 to get 90. This is giving us A straight away. So this is a second way of solving the question, the earlier question we solved. Okay. Now let's move on to the current question. The angle of minimum deviation for a glass prism with refractive index equal to root of 3 equals the refraction angle of the prism. Well, all that the question is saying is that the angle of minimum deviation, is equal to the refraction angle of the prism. That is all. What is the angle of the prism? And note that the angle of minimum deviation, so we are at a condition known as a minimum deviation. And at the minimum deviation, the refractive index is equal to sine of minimum deviation plus A, all divided by 2, close the bracket, also divided by sine of A over 2. We are told that at the minimum deviation, that is equal to A. So substitute A for wherever you see the minimum deviation. So this is A plus A all over 2 divided by sine of A over 2. Okay, so the numerator would give you sine A divided by sine of A over 2. So this approach is similar to what we just used. That's one. Okay, so when we expand the numerator, of course, since 1 is equal to half plus half, this will give us sine of A over 2 plus another A over 2 divided by sine of A over 2. Okay, when we expand, the numerator would, the whole expression will be equal to 2 cos A over 2, just as we had. Therefore, the refractive index, which is root 3, would be equal to 2 cos of A on 2. When we divide through by 2, we have cos of A on 2, giving us root of 3 on 2. What is the cos inverse of root 3 on 2? What is the cos inverse of root 3 on 2?
30.
Good. So this will give us 30 degrees. So that A over 2, which is equal to 30, A would be equal to 2 times 30, which is 60 degrees. So this is the refraction angle of the prism. Let me see by hands those of you who got this right. If you got 60 degrees, let me see you. Saki got it. Oh, Janelle got it. Kingsley. Okay. Alikem, Zaratu, Joshua. Oh, then that's good. Please, is there any question? Is there any question? If you have any aspects you are not so clear about, please let me know and then explain it.
Sir,
Hello.
please go over the solution for me.
Okay. So the whole trick in the question is this part. Understanding that the angle of minimum deviation is equal to the refraction angle of the prism, this part.
Why are you spoiling the movie for me? Please, I've not watched the thing.
Angie,
It's giving too much
Angie,
information.
Angie, you are spoiling our movie.
Sir, please, I'm sorry.
Okay. So the next thing is that you must be able to identify whether the question is at the minimum deviation or not. If it's at the minimum deviation, then use this equation for finding the refractive index, okay, which is what is stated there. Then substitute, since minimum deviation is equal to A, substitute A for minimum deviation in the formula. So sine A plus A over 2 divided by sine A over 2. Okay, the numerator becomes sine of 2A over 2. And then the denominator is sine of A over 2. This 2 will cancel out so that we have sine A divided by sine A over 2. Please note that this is trigonometry. A and A cannot cancel out. Okay, but you have to manipulate the numerator. Of course, I know 1 is equal to half plus half. So if I have sine A, then this is also the same as half of A plus half of A would give me A divided by sine of A over 2. And I'm doing this so as to help me use the identity. I mean this identity to expand what I taught you, this one. Okay, sine A plus B is equal to this. This is what we use to expand. So meaning that this is A and this is B. So if I have this, the expansion of this is equal to sine A over 2 times cos A over 2 plus cos A over 2 times sine A over 2, double angle. So it's a kind of double angle. This is the numerator divided by sine A over 2. Okay, since multiplication is commutative, this part is the same as this part. So we'll have this to be 2 sine A over 2 cos A over 2 all divided by the denominator sine A over 2. This time around, sine A over 2 can cancel its corresponding that, so that we'll have the refractive index being equal to 2 cos A over 2. Please note here that the angle is A over 2. That's fractional angle there. We're given the refractive index to be root 3. So root 3 is equal to, we are looking for what the angle, which is A over 2. So we eliminate this. When we divide 2 by 2, we have cos A over 2. Take the cos inverse. When you find the cos inverse, it means you are looking for the angle. And so the angle A over 2 is equal to the cos inverse of root of 3 over 2. And that is 30 degrees. Cos inverse of that is 30 degrees. you can then determine the value of A. Okay, A therefore is 2 by 30, which is 60 degrees. So that's the solution to the problem. Please, is that okay?
Yes, sir.
Let me go back to the graph to talk about it for a while. I wasn't so impressed with the outcome or the output some of you sent to me at all. Where is the graph question? Good. So let me repost it to the page for our consideration. So the graph is on the page. Please open it and let's discuss it. My phone seems to be messing around. Give me a minute. Good. It's right here. All right, so explain the statement that the refractive index of glass is 1.5. Yes, here some of you gave me very nice responses. So the refractive index of a material is the measure of the material's ability to bend or deviate light. So if the refractive index of glass is said to be 1.5, then it means glass can bend light 1.5 times as can be done by air, or glass can bend light 150% as can be done by air. Some of you also said it means that glass can slow light, the speed of light, okay, 101.5 times as can be done by air. Yes, these are all correct and in fact very much accepted. In an experiment carried out with a rectangular block of perspex, the following readings were recorded. Let me quickly share with you these values. R sin I and then sin R. I value 22, 28, 33, 38, and 41. Angle of refraction, this is 15, 18, 21, 27, and 26. And the sine value of I 0.3746. The sine value of R 0.2588. Sine of 18. This is omitted. This is also omitted. Sine of 33. 0.5446, 0.3584, sine of 38, 0.6157, and then 0.4540. Then the last sine 41, 0.6561 and 0.4384. And you have to complete the table and then plot a graph of sine I on the vertical axis against sine R on the horizontal, and then use your graph to determine readings. Okay. You see, if you look at the angles of refraction, as I increases, so in a table of value, if you ideally you must express the units. So to stop or prevent that repeated writings of the unit to the values at the column, I slash the unit of the quantity degree. The moment you do that, okay, it eliminates where you'll be indicating the angles here. So if you bring it here, you don't indicate the degree within the values. Okay, similarly, R slash degree, so that you don't repeat the unit. Note that sine values, sine, cosine, tangent, logarithm, or log values do not have units. So sine I, sine R do not have units. When you bring units, we'll deduct 1. The next observation is that as I increases, the trend for R is that R must also increase. So 15, 18, 21, 27, and 26. These two readings are not correct, meaning that we must have 26 coming before 27. And when you are doing the real practicals and you have values of this nature, you must take your measurement again, meaning something is wrong somewhere, because there must be a consistent order of increase of it. We can't have one increasing and also decreasing, no. So ideally 26 must come before 27. Please, is that okay? Are we okay? Oh, let me have your views.
Yes, sir.
All right. Now, the omission. This is simple. What is sine of 28? Quickly, give me the value of sine 28 in 4 decimal place. Sine 28. Is it 0.4?
0.4695.
4695. And sine 18.
0.3090.
0.3090. Okay. You see, these values, because the difference is not so big, that is why here is not showing. The inconsistency is not showing in sine I. Okay, it's because of the value. But sine R is showing. Okay. Now, in plotting I against R, you choose scales. It is always wrong to choose scale in plotting this, because these are 4DP. Somebody may not be able to plot. It is difficult to locate 4DP on the graph. Okay, usually students will want to run their values to the nearest DP. In fact, if you are fond of running up values in practicals and plotting, the more or the closer you run values to, the more error you introduce into your values. Also, it is always advisable to plot graphs around 2-3 DPs. Okay, if I want to use 3 DP, it is difficult to locate 0.375 on the graph. I have 12 vertical 2 centimeter boxes. I have 10 horizontal 2 centimeter boxes. It is usually very difficult to do this. So the best way to do this is that you can express your numbers, your plotted values in standard form, plotted values. And some of you did that. So sin I, sin R. If I want to express this to maybe standard form, but I'm running it twice. So I have 30. The first one I have 37.46. Okay, here because I'm running it up to in that manner of standard form, I must bring so sin I slash 10 exponent -2, meaning this will take care of that consistent expression of standard form. So 37.46, it can be 3, it can be 4. Okay, then the next one will also be 46.95, 54.66, 61.57, and 65.61. Then I do the same thing to sin R as well. So sin R slash 10 exponent -2, because the first one was expressed to that, I must do the same. If you want to do it to 3, the same thing. So that you have 25.88, 30.90, 35.84, 45.40, and finally 43.80. Okay, meaning that these are the values you are going to use in choosing your scale. So in choosing your scale, then okay, let me divide this into. Angie.
So please, does that mean that it is the sin I and sin R values that will be plotted on the graph, not the
Yes.
actual I and R values?
Angie, listen to the instruction. Complete the table and then plot a graph of sin I on the vertical against sin R. Is that okay?
No.
They are
Yes.
actually the values of sin I and sin R, not I and R. Kingsley. Kingsley, please speak up. 43.84. Okay, yes, thank you. So because I have expressed them in standard form. These are my values, but I must indicate that sometimes time or slash to the power -2, so that everybody who takes this would be able to see that yes, that's what I've done. 10 exponent -2. Okay, it means I'm going to plot this value. My minimum value is 37.46 and my maximum value is 65.61 for the vertical. So assuming, let me divide it into the 12. Let me divide it into 12 equal parts. So this is half. 1, 2, 3. 1. Good. Just to help you understand. Let's assume a ends here. 1, 2, 3. Good. So I've divided the vertical in two. Now your graph must always cover about 2/3 of the page, meaning vertically, if I divide this whole 12 divisions, my graph must cover, if I divide it into 3, my graph must cover 2 or 3/4. Okay, this is 1, 2, 3. So it means that if I'm dividing this, it must, meaning your graph must not be smaller. So how do I choose my scale? These are my values. The minimum value is 37. The maximum value is 65. Supposing I'm going by 10, 10, I'm going to have 120. 120 is in excess. Are you okay? Supposing I'm going 5, 5. So this is 5. Clearly, this will be 5, 5, 10, 20, 30. Oh, did I say, I think 5, 5, right? So 10, 15, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. But the point is that the first point to plot would start at somewhere this point, okay? Because your minimum value is 37.446 or 37.5. Your minimum value will be here. Then what about the horizontal? The horizontal, your minimum value is 25, maximum value 40. We have 10 values, 10 divisions. So if I'm going 5, 5, in fact, the maximum will be up to 50 and it would also work out. Please, I hope you are following. So since I have 10 divisions, if I go 5, 5, 15, 20, 25, I'll get 50. And my maximum is 45. So I can be able to plot. The only thing is that here too, I will only plot when I get to 25. So my first point will be here. First plotted point will be here. The next will follow on and on and on. Okay. Please, is there any question here? Is there any question up to this stage? Gideon, please hurry up.
So please, when you are plotting the sign out, the interval between 0 and 5. So it means each box will be 0.5. But then you have two decimal places, and then each box is to one decimal place. So how are you going to plot like for the
Good.
those two
So,
decimal places?
okay, so supposing I'm to plot the first value, 37.46. 37, we have 10 divisions between every 2 centimeter, right? So if we have 10 divisions, then it means the interval between 35 and 40 is 5. If we have 10 divisions, okay, if we have 10 divisions, then it means that every 2 division will be 1. So if I pick any 2, 36 will be 2 of the smaller boxes. 37 will be 2 of the smaller boxes. Then I come to 0.46. You see, here it is difficult to plot the decimal point. The best I can do is that run this to 37.5 and choose half of that smaller division box. Please, are we okay? The best I can do is that I have smaller divisions. I'll just choose half of it because I have 37.45. I'll run it up to 0.5 and choose half of the smaller box. Please, are we okay?
So please,
Gideon.
but if one box is 0.5, can't you just choose the line on one box? If you
No,
want
what
me
I'm
to
saying is that
put 0.5.
37 must be 4 of the smaller boxes because one is 0.5. So 2 will be 30, 2 will be 1, 36, 37. Then that will cater for 37. But the next one is a decimal point, 46. I cannot get 2. It is even difficult to plot this first one. So I'll only run it to 37.5 and choose half of that smaller 0.5 box. Gideon, are you okay? Or better still, I'll plot it using this 37, meaning I'm plotting it to 2dp. That is also correct. Gideon,
Okay,
are you okay?
okay. Yes, yes. So it means for the next point, it is 46.95. We're going to plot 47.
To be at the safer side, I'll plot 47. Are you okay?
Okay,
The
sir.
next one,
Yes,
I
sir.
cannot locate 0.7 on it, so I'll plot 55. Okay. The only thing is that we don't advise to run plotted values to the nearest DP. Over here, wow. No, that is why we express it in standard form. When you express it in standard form, it helps you to choose correct scale. Choosing scales using these values is easier than using this one, 0.374, true or false? Class, is that true or false? So we express it the values in standard form, one, to help us choose our scales easily and also determine our scale, our slope and others. Now, so let's assume my plotted points are here. In fact, it's raining here. If I'm able to get all my plotted points to be in a straight line, I'm good to go. I can draw the line of best fit. I can draw my straight line easily. But here is the case. One is even shifted. The incorrect one is shifted. Meaning I have to draw my line of best fit. How do I determine the line of best fit? I have a lot of points. So let me clear some of them. And this awkward one. Now, if I choose my line of best fit this way, seeing that these three would accurately join, so I put them together. Let me even bring this one here to the line. When I choose my line of best fit this way, do you know this is wrong? This is wrong because when you choose your line of best fit, point which couldn't match should not be skewed to one side. There shouldn't be one side of the straight line. This point which could not join must be distributed around the line of best fit. So I cannot choose this line of best fit where these two are at one side of the straight line. Please, are you people there? You seem to be quiet, not talking, not responding. So this is a wrong line of best fit. The correct way to choose the line of best fit must be this. Knowing that the point must be distributed around the line, I can pick this. So that at least I have one here, and these two are distributed around this. Note that your line can start from the origin or can be an intercept, depending on how you can accurately draw your line of best fit. So this is correct. The pink color line is correct. This line of best fit is actually not correct. Is there any question? Then the slope. I saw some of you using creating sine of I over sine of R to calculate this, finding the average. Please, in determining the slope, you choose any 2 points. It can be already made points or non-available point. Find the change in the vertical, change in sine I. Kingsley. So the slope of this, which is equal to the refractive index, must be sine I over sine R. Okay, so that reading this from here, there's a vertical, maximum vertical, minimum vertical. The difference will give you change in sine I. Then maximum horizontal. Yeah, Kingsley. The minimum horizontal, the difference would give you change in sine R, and the ratio is equal to the slope. All right. Please note that there are times where I can decide to break this graph. What do I mean by breaking this graph? When I look at my values, my first point to plot is 37 points, meaning from 0 to 36. I wouldn't plot anything. So if I started from 0, 0, 5, all this part will be wasted. All this part vertically will be wasted. So in order not to do this, I can decide to start from 35. So 35, maybe 37, 39, 41, blah, 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 till I get my maximum value of 65. That is also can be done. But choosing that depends on the question. If you are not restricted or asked to start from the origin, you can break it. If you are told to start from the origin, then you cannot break your axis. Frank.
Sir, please, so how would the scale be derived from moving from 0 to 35?
So this is what, let me clear this. Knowing that I wouldn't plot anything till 37, I would decide to break the graph. But that is, you can decide to do so from how the question is structured. So 37, 39, I want to do it 2, 2, 2. 2 units for every 2 centimeters. So the next, okay,
41.
the next, I can even start from, okay, 35, 37, 39, 41, up to my last value. And I can choose this knowing that I can have my minimum and then the maximum value 37 and then 60, roughly 66. Okay, so Frank, I can still choose my scale, and that is every 2 centimeters, it must be equal to 2 units. Okay, because 35, 37, 39, 41, 43, 45, blah, blah, blah. So it means that vertically, every 2 centimeters is equal to 2 units. Frank, are you okay?
Yes, please.
Gideon.
So please, in choosing, like in finding the slope, so please, the sign R, you said, can you come again on that part? The change in sign I over change in sign R.
You see, this is change in sign R, change in sign I. In determining this change, is the difference along the vertical. This is different. So you read the maximum value here. So you read it here. Maximum vertical value. This is 50 something. And this is 36. So this is maybe 35, 53. So it's 53 minus 36. That will be change in the sign I. Change in the sign R, maximum horizontal value from where, okay, you read it here, and then minus the minimum horizontal value would give you change in the, when you divide vertical by horizontal, it is the same as what you do in math to find the gradient. Y2 minus Y1 divided by X2 minus X1. Y is the vertical axis. Don't forget this Y axis and this is the X axis. So it's the same as what you do in mathematics. Gideon, are you fine?
Yes, sir, thank you.
Please, you do not forget about your skill. You must always state your skill. Okay? How do you write a skill? You write it at the vacant part of the whole graph area. Okay? 2 centimeters to 2 units at sign I, then the X. Maybe 2 centimeters to 5 units at sign R. And when examiners are marking, this will attract half. And so the scale will give you 1. That is why when I was marking, I talked about omission of scale. Then your well-labeled axis, the vertical axis is sign I, half mark, Horizontal axis, sine r, another half mark. So you always do not forget about your scale and then your axis. When you must also close your axis using the arrow. Is that clear? Then the next question, you were given sine 20, I think sine 25 to find r. You can do that using calculation or on the graph. If you manage to get the gradient correctly, you can use Snell's law to do that. I think I explained this to you last time. If you want to use the graph, find the value of sine, is that 25 or 45? I think it was, as a question, I think, okay, 45. Sine 45, and that is 0.7071. So plot 0.7071 on the graph, on the sine I value. When you express, this will be 70 point something. Okay, so you need to create, because of this, when you are choosing it, you need to create something for it so that you could get a value for the sine I, which is 70.1. So you trace 70 point something on the I. When it touches the straight line, you link it to the sine R and read. Whatever the value is, it means that sine R is equal to whatever value you had here. Okay, then you take the sine inverse to find R. So I'll look for another practical work. This time around on refraction of light in triangular prism. Then give you values, so you plot. That will be part of this weekend's assignment. Okay, in order to help you choose scales, find slope, and all that. Class, is that okay? When it comes, I beg you, find time to do it. Do not, run away. If there is any question, quickly ask, because we have just a minute to end our lesson. Is there any question? Michelle, is there any question?
Sir.
Echo.
Sir, please, in the question you asked us about the value which was, say, distance from the slope. Sir, can you say it's because it didn't fit the line of best fit?
You see, I explained that. Earlier. What I was saying is that, you see, practically, as I increases, R must also increase. So we have 21. The next value must be less than this one, less than 26. So ideally, 26 must come before 27. And this is what is responsible for this point, which is skewed away from the straight line. Are you okay? So when you do this, and in practicals, you have such inconsistent values, you must check your measurements. Michelle. Michelle has gone to Michelle Camp. Okay, so if there is no question, then class, this is where we draw the curtains on our meeting today. Okay, we'll continue next week. Next week, we have to run through lenses. Yes, since we've done mirrors, spherical mirrors, it will be easier. Okay, so we'll run through it and then quickly start with heat and temperature. All right, so we'll continue our discussion next week. Please have a very nice weekend. The assignment would, as usual, be sent on the platform. Bye-bye.
Bye.
Bye, sir.
Bye bye.
Bye.